later. Um, to graph this, if you just go to your y equals like normal, you can't really graph a polar. But if we change the mode, then you can graph polars. So go to mode. It's in the top row there.
Oh.
Yeah, and go down. We do want radian picked. And then where it says function, you've got function, parametric, polar. We want to pick pole for polar. So radian and polar should be highlighted for you. Then when you go to your y equals, it's no longer a y equals, it's an r equals. And when you push x instead of x, it'll come up as theta. Okay, but again, you've got to be in the right mode, radian, polar, and then you can graph polars. All right, so try to graph those in that warm-up. I will come around and look at your homework. Yeah, and in your notes packet, I believe. Zoom fit or sometimes Zoom trig works. Lots of different options there. Kind of ugly. You don't like it. Yeah, it's a little.
Oh no.
All right, guys. The homework was lots of pages today.
I'm so confused what's happening.
What is in trade?
That's what I did, but look, it's just nothing's happening.
I got this. Yeah, 8 times.
Yeah, X is
Picking up butts.
That's fine. Four.
Oh my god, I put in the wrong numbers.
That actually is pretty. It's just so like even.
And this is also yeah, this is 8. Yeah, so I don't know. 4 is 8, and 4 number is 8. I don't know. What is the pattern for the number of times? What is the pattern?
If your graph looks weird, you can always pick Zoom trig.
Biggest fire
So I just so yeah, what is the pattern?
Giants little bit.
Oh, wait. If it's inside the statement, you multiply that number by 2. If it's odd, it's that number.
I don't. Sticking up right there. I don't know the if the coefficient is 5, it's 5. So just say that it's 5. No, I have no idea.
B times 2.
If literally 0 is 1, no. 5 times 4 minus 7 I bet it's divided by 4. So 5 times 4 is 20.
You do not.
I mean, what do I have? Minus 45.
Everyone was like, yeah.
It's even, you multiply it like that, it's even, you multiply it by 2, and that's the math. The odd stays the same.
So smart, Matthew.
I feel so
So impressive. Yeah.
like that.
Like, I know stuff.
Can you put the A in the question? That C and B all have the same. But
5, like literally.
I think that's like where it is on the translation. Like, I think if you graph
Can you tell what the equation represents? You
It looks like it's getting bigger.
Oh, that's not the trumpet, it is.
Wait, go somewhere. It's yeah, like something that's like defined by pattern. So like determines how long the rose petal.
Ding, ding, ding. Matthew is on fire today.
Oh, no, it does.
Yeah.
Yeah, okay.
I can't.
The radius is
So,
the, the radius is
Yeah. The radius is the same. The thing.
first coefficient, A.
I've done my math here. Determines how long the rose petal is.
No, that's like the orientation. And then the theta, if it is similar, if it's not, the coefficient is when theta is plus 100, it's not. Or sorry, if the coefficient is 1, so the number of petals is down, the coefficient is 1. If it's even, it's 1. It's double. Yeah. And then what random number? And then A is R.
Minutes, go ahead, talk to each other.
Yeah.
I should have done it. What is?
That's off the base. Yes, the number of base.
Yeah. Odd. Bro. Coefficient.
Yeah, this one gives you 8 for 100. 20 to 20.
If that makes sense.
I go,
Oh, maybe.
no, it's only 20.
Data.
Are we ready, guys? We need a minute. All right, guys, so let's fill this in. How many petals for equation B there? 8 petals, yes. What about C? 5, and D? E, F, G, and H. Okay, so guys, what's the pattern for how many petals your rose is going to have? Matthew.
If it's even, it's the B times 2.
Okay,
And if it's odd, the B is equal to the 9 petals.
good. So if B is even, then you do 2B for a number of petals. And if B is odd, just B equals number of petals, okay? Did you guys all notice that? Found that? Okay, what about A? What does, oh, yeah. So that is the B value? And that's odd, right?
Oh,
All right, guys, then what does A represent? Okay. Yeah, so like length of the petal. Yep, exactly. So A is just the length of the petal. All right, and then guys, you can go ahead and put your calculators away. We won't use them to actually graph these with our notes and everything, but good little exploration for you to see some of those patterns. Oh, and guys, sorry, before I start, did anybody have any homework questions? Anything they had issues on from the homework? Or were we pretty okay, especially graphing the whole Lemicon? Okay. Yeah.
so is it okay if you only like for the R and theta table, can you find like half the points and then just use like the symmetry to
Yes. Yeah. We want to, I mean, really the idea is to get to the point where you don't
have to
need a full table. It's just, it takes a while to get there. So yeah, as much as you can just think about it and figure it out, I am fully in support of that, okay? I'm not going to look at it and be like, you didn't make a full table, you don't get credit. Like, no. If I'm like, oh, good, you understand what's happening. That's where we are.
How many more units do you have?
So we're obviously on unit 8. We're going to do a conics little like mini unit that won't actually have a full test. Then we have 2 units of calculus. We're kind of skipping what our old unit 9 is, and if we have time at the end, we'll pick that up. But it's like sequences and series and parametrics. If not, if you're going to BC, I'll post what you need to know. It's like a 2-day lesson, so it's not a big unit. But yeah, that's it. Kind of crazy.
Yeah.
Yeah. Basically, the whole fourth quarter is calculus. Good times, right? Good times, everyone. All right, so let's graph our roses today. So first, without knowing anything else about this graph, how many petals is it going to have? 3. We now have 3 petals. Okay. How long will they be? Okay. Length of 5. And symmetry. It's a cosine graph. So what is it going to be symmetric to? The x-axis. Yeah. So when we get done at the end, you should look at your graph and go, yes, that is symmetric to the x-axis. If it's not, something has gone wrong. So there's a couple ways you can go about graphing it. We could obviously plug in thetas and evaluate all the way around. It's actually kind of hard to do that because of the 3 in there. Like if I plug in pi over 3, when I go to evaluate it, I'm really evaluating pi. And it's a lot to think about to try to plug things in. So I'm going to show you another way to do this without actually plugging in a bunch of thetas all the way around. Now, when it's a restricted window, yes, you'll still have to think about that a little bit. But let's look at how we can figure out where those petals go. So I'm going to start up here by just writing the equation 5 cosine 3 theta. And I'm going to say instead of equals r, I'm going to say equals 5. Why can I do that? What do you think, Vera? Yeah, that's like the maximum, like the end of the petal, right? And that's what I'd like to know where it is. I'd like to know where the very end of the petal is, because if I can plot that, I can draw the rest of it. Okay? So the maximum it could be is 5. So I put that in there. So my first step is to divide by 5. And so I have cosine 3 theta equals 1. You can absolutely start your work here. If you get that, like, okay, it's always going to be divide by that and I get 1 no matter what. That's going to happen every single time you do this. Okay, so if you want to just start there, that is fine. Now we are back to solving a trig equation. You guys remember doing this a couple units ago? Maybe.
I wish I could.
You're like, oh dear, we have to remember things? Yes. So remember, we are thinking about when does cosine equal 1? Like, where does that happen?
0.
Okay. I'm just going to say 0, and I'm going to say plus 2 pi k, because it would happen there over and over. So then I come back over to the equation I wrote on the left here, and it's not really theta equals that, it's 3 theta equals that 0 plus 2 pi k. What do I do next? Divide by 3. So theta is equal to 0 plus or minus 2 pi k over 3. So my angles, what are they? What's the first one? 0, 2 pi over 3 is the second one. What about the third one? 4 pi over 3. Should I keep going or should that be the end? Yeah, that's it. Because if I kept going, I'd get back to 2 pi and you just keep going around your circle. And it makes sense. I have one answer over here, 1 times 3, the coefficient on theta. That gives me the number of answers I should have. So hopefully that's familiar to you. So what we do with these points, the maximum length of the petal of 5 happens at 0, at 2 pi over 3, and at 4 pi over 3. So I'm going to plot those points. I'm going to go out here 5, 0. I'm going to go 5, 2 pi over 3. And I'm going to go 5, 4 pi over 3. What do you notice about those dots? Yeah, it's like evenly spaced all the way around, right? Your petals should always be evenly spaced like that. If you ever have two petals really close and one far away, something didn't go right. Go try again. Another point that we also know will always be in our rows is the pole, like the center here. So that is a dot. So I've got 3 dots. I can now draw the full rows. So technically you should draw it without lifting up your pencil, but it's kind of hard. I'll show you. It's like a spirograph, yes. I kind of need a bigger dot in the center there, but you get the idea. Hopefully your petals are the same size. Mine are not exactly the same. But I'm not looking for like a bunch of points plotted along the petal, okay? I really just need the end point. Remember, it's very circular, so keep them roundy. Don't have super, super skinny little petals. That's not what they look like.
Mine's not going well.
It's a challenge. And the reason I graphed in that order that I did, that's the order the points actually occur. So if I had to do like a certain window of it, that's the part I would graph. And we'll get to that in a little bit. All right, questions on that one? Okay. I don't know if I want to make you do the one with 5 theta. Let's change this to cosine of 2 theta, guys. 5 theta is really ugly to plot, so let's make it 2 theta. That's not pretty, but you get the idea. Okay, I want you to try to graph it. How many petals is it going to have? How? 4, right?
Oh.
I changed it to 2 theta.
Oh.
Sorry. How long are the petals? 4. Okay, so start your process. At least find 2 of the petals for me, and then I'll walk you through the rest of it if you get stuck. Are you guys getting 2 petals? Okay, that's good.
Oh, wait.
I'll explain how we find the other 2 petals then.
I'm pretty sure it's like, I'm not
It's probably like the first one.
Oh.
So are you guys getting 0 and pi? Okay, so let's plot those. So I've got 0. Oops, not 5, 0, 4, We got pi. We know we have the pole in the middle. Now, what did we say about how the petals like sit on the graph? Equally spaced. So where are your two other petals going to go? That's it. You just know that and you put them there. You don't have to algebraically find that. You just go, okay, I'm at the top. I'm at the bottom. And then again, try to graph in one smooth.
Would you ever dog points because of the ugliness of a graph?
Well, how ugly are we talking about? Like, can I tell that it's like a rose, or does it just look like a blob? Oops, forgot my last. I mean, mine aren't perfect by any stretch. I'm also drawing on this thing, which is harder than paper.
It's going so well until it's not going well.
Are you guys doing okay with like seeing how you can draw it by not picking up your pencil, like that order? Okay, good. Questions so far? Okay. Let's do the next one. All right, guys, we've got r equals 3 sine of 3 theta. Let's graph this whole thing. So you guys try this one. It's a sine equation, not a cosine equation. So what is this going to be symmetric to? The y-axis, yes. You see why it's pi over 2?
Yeah.
Okay. Yep. Are we getting one angle at pi over 6, guys? Yes, okay. Where's the next one? It's harder with sine. You have like harder fractions to add. 5 pi over 6, good. And our third petal?
3 pi over 2.
Excellent. So length of 3 pi over 6 over 6. Oh. Did you guys notice that I actually started graphing this one at the pole instead of out at the end of the petal? Like when I graphed it, here, let me just do it again. Why would I begin this one at the pole and go this way? Why do you think that's, I mean, just because I feel like it?
Yeah.
No. Wow, I really missed in the middle there. Think about sine. What is the sine of 0? 0. So that's, if we're graphing this from 0 to 2 pi, you start at 0, 0. And then you go out to the end of that first petal and down and around, okay? Whereas cosine, what is the cosine of 0? 1, it's that maximum length. So you start out at the petal if we're graphing it from 0 to 2 pi.
Why does it matter?
If you're graphing the whole thing, it doesn't matter. If I said graph it from 0 to pi over 2, you'd need to know, like, okay, well, what is it at 0? That's where I'm starting. All right, guys, questions so far? Okay. All right, turn the page. Okay, this first one, 4 cosine 2 theta. We're going to graph this with theta values from pi to 2 pi. So 2 ways you can do it. You can think about what the whole thing would be. You can actually plug in values from pi to 2 pi to think about where they would be. I like to still think about where those petals are occurring just to make sure, like, I have that in my brain. But then you can plug in if you need to figure out which part of the graph we'll graph. So I'll give you a minute here to try this one, and let's see how we do. Talk to each other. Come up with some sort of strategy.
That's cool. That makes sense.
Like, it makes sense. I don't know if I'm right. Give you another minute, then I'll show you. You got it, David? No? If you were graphing the whole thing, would you be okay? If you were graphing the whole thing from 0 to 2 pi, would you be okay? Okay, but the window is what's... Remember that this doesn't mean graph from pi to 2 pi. It just means the thetas you can plug in are between pi and 2 pi. Okay? Remember, like with our circle that we did on that one homework where it was like, oh, it's not no graph, it just means, yeah, same idea.
But then I mean, what are people saying with theta here?
All right, guys, if I was graphing the whole thing, this is what the entire graph would look like. I'd start out here. Maybe. Back around here. That would be the entire graph, right? Pi to 2 pi, how much of the graph am I going to see? Half. Which half? The first half I drew or the last half that I drew? The last half. So let's think about this. Go over it in a different color. This was the first part that I drew. So the red that's left is what the actual answer should be. So let me erase. Okay, we're stuck. Hold on. I'll do more. That is what your graph should look like. Did anybody get it? Yay, good job. Okay. All right, if you're like, wow, my brain does not understand the order that these points are going in, like, I don't get it. Okay, then we will plug in points. We're going from pi to 2 pi, so let's plug pi in. So when I plug pi in for theta, that's really saying the cosine of 2 theta, right? So what's the cosine of 2 theta? Okay, I see faces. When we plug pi in, theta's pi, right? So if I go into this equation and put a pi right there, isn't that now saying cosine of 2 pi?
Yeah.
Okay, what is the cosine of 2 pi? 1 times 4. Okay, so that's our first point. I'm going to try 3 pi over 2. I'm only going to do a few points here. If I plug 3 pi over 2 into that, what am I actually taking the cosine of?
2.
3 pi. The 2's would cancel, right? Because if you did 2 times 3 pi over 2. Okay, so what is the cosine of 3 pi? -1, so the r would be -4. And then let's plug in 2 pi. So if I plug in 2 pi in, that's really saying the cosine of 4 pi. What's the cosine of 4 pi? 1 times 4 is 4. Okay, I'm going to erase my graph here and redo it again for you guys. So we want to plot these in order. So 4 pi, that's my first point over here on the left. Where is -4, 3 pi over 2? It's at the top, right? Here. That's your next point. And then where's 4, 2 pi? Over on the right. And we didn't pick any theta values that would give us the pole, but we know we have to go through the pole, right? Repeatedly. Okay, so I'm going to put that point in. So remember, it was 1, 2, 3 if we're doing connect the dots, you know. So you start at 1. The only way to make that work to get up to 2. To come back to 3. Okay. Yeah. So could I, if I went up, does that lead me to point 2 next? Without like making some sort of weird corner? And you don't do that. You graph in like spirograph circular motions, okay? Redo that one more time. So the only way, if I'm going from 1 to 2, I know that that's the circle. And that's the circle. You see it? Okay. We're going to practice more, don't worry. Okay, let's try again. This next one, r equals 5 sine of 4 theta. I want you to just graph that entire thing. We'll go 0 to 2 pi, okay? We haven't done any with quite this many petals, so I want you to try that one. How many petals are we going to end up with? This many, yeah, 8. Good. All right, so try that. See if you can figure out where they are, too. That's a little bit awkward. It's going to take you a minute to figure out where these actually go. That's okay. Did you guys figure out where one petal is? Pi over what? Pi over 8. What is that in terms of degrees? What's pi over 4 in degrees? Okay, so it's half of that. What's half of 45? 22 and a half. So that first one is in the middle here, right? When you get to the end, I'll show you how you can do this with a little less work than all the work you're doing right now, okay? A lot of it is just...
Which point did you go? You go to like...
Oh, like the order?
Yeah.
I'll show you. Hello?
I figured out where the points go, but I
It's
don't
like...
know.
Yeah.
It's all about making them evenly spaced. That looks good, yeah. I think you've got them.
I'm sure I have my points.
So guys, you can certainly go through and go, okay, 22.5 degrees and figure that out. And you can go through all the pi over 8s. I look at it and go, okay, that is like 1.5 tick marks from the x-axis, right? Like from 0, this distance here, right? 1.5. So I'm going to go ahead and try doing that from each axis because I know the spacing must be equal. So I know I'm going to have this point in the second quadrant, this point 1.5 away in the third quadrant, 1.5 away in the fourth quadrant. Now you just need to split the distance in between each of those points to find the remaining 4 petals. So you can count like halfway in between if you want. Like I see that that's 1, 2, 3, 4, 5. Like it's a distance of 6 to get there. So if I go 1, 2, 3 and put a dot, and then 1, 2. Do you see how that evenly spaces them? Okay.
Go back from the axis.
You can also go back 1.5. Absolutely. So you go 1, 2, 3, which is the same as back 1.5. Okay, so it's all about getting that spacing even. And you know you'll go through the pole. Okay, as far as how to connect these, like what is the proper order? So when you go to draw it, it's a sine one, so I know I actually start at the pole. So I'm coming out to the first point. Then you come back and you're like, okay, where do I go? You don't make a big turn. Like it wouldn't work to come over to this one. Okay, like that's too much of a turn. You also can't just like go straight across to one. So that leaves the option of this one. And then you follow that same process. I'm not going to go straight across. I'm going to go like 1 away from straight across. 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 And oh my goodness, we're almost done. Did that order make sense? Like you can't like force it to another dot. It's got to like flow to the next one. That's the order it'll go in. It's still hard if I give you a different window. If I say like 0 to pi over 2, you then have to think, okay, well, where am I stopping? How much am I seeing? All of that.
I know, that's what
You what?
Like overlap.
Oh, like they're wider?
Yeah.
Yeah, I know mine. That happened with mine a little bit in the middle too. It's okay.
it would be so pretty if I could actually draw it right.
Questions on that one? Okay, let's try another one. Another sine one here. 3 sine of 2 theta. So how many petals should it have? 4. I'm going to have you graph it from 0 to pi over 2. Do you know already how many petals you're going to have in your final graph? Good. How we doing, guys? Check in with each other, make sure you've got the same thing. If not, figure out who's right.
So when it says however, can you just know that you're gonna have like a quarter and then when it's like pi, it's a half, 3 pi or 2. Just
The weird part is like a quarter of a cosine graph looks different than a quarter of a sine graph, you know, because of your starting point. So. Well, and obviously which quarter it is makes a difference. All right, guys, let me graph the whole thing, and then let's figure out what 0 to pi over 2 would look like. So I know 3 sine of 2 theta. We're going to have 4 petals total. And are we okay with they'd be at like the pi over 4s? So 1, 2, 3. And again, this is if I was graphing the entire thing. Okay, when you're graphing a sine graph, does it start at the pole or does it start out at the end of the petal? The pole, okay. So I'd start at the pole, and I'd go here. So if I'm graphing it to 0, from 0 to pi over 2, that's a quarter of the graph, right? Do you guys see how it's going to be that first quadrant petal, and you do get the whole petal? Okay. Yep. So that is your graph. Lonely little petal. All right, questions so far? Okay, let's turn the page. We're gonna skip. You already know the stuff at the top, so. And we're gonna save writing equations for next time. So let's just try these 2 at the bottom here. 4 cosine 3 theta from 0 to pi over 2, and 4 sine 3 theta from 0 to pi over 2. Try to graph both of those. And there's something interesting with this one. Since the petals are odd, it's a little different. You get like 1.5 petals. Yeah. Guys, the 0 to pi over 2, that's only a quarter of the way around 0 to 2 pi, right? But how much of this graph do we actually get? You get half of the graph. Now, let me explain why. When we had our even graphs, let's go way back to the beginning. Like, let's look at this number 2, where we graphed 4 cosine 2 theta, and we were graphing it from 0 to 2 pi. We got double the number of petals, right? So instead of 2, we got 4 petals. With the odd ones, when we graph this from 0 to 2 pi, it's actually going here, there's to pi, and then it goes around a second time. So it still graphs 6 petals, but it's the same 3 petals 2 times. So for this one where you're doing this smaller window, even though this is only a quarter of the unit circle, it's actually half of the petals. Does that make sense, guys? Because this is odd. Because you draw the same 3 petals twice by the time you get to 2 pi. It's like when we did the circle, remember how it would go around twice? So when we saw a quarter, like 0 to pi over 2, that actually graphed half a circle. It's the same idea. Some of you are looking very skeptical right now. So guys, let me graph this one. It's cosine 4. And then we would be, if you were graphing the whole thing, it'd be at 2 pi over 3 and 4 pi over 3 for your other points. Right, you'd be there. So here's where 0 would start. Come out here. That is your graph. Yeah, we got it? Okay. So odd versus even petals, slightly different rules for you there.
You figured that out. Where to start?
Okay, so
Values?
cosine, what's the cosine of 0?
The cosine of 0?
Mm-hmm.
1.
1, and what's 1 times 4?
4.
So I know every time the cosine is going to start out at that maximum of the petal. Whereas sine, what's the sine of 0?
0.
Okay, so that's why the sine graphs, you actually start in at the pole. You're like, yep. And if you had made a little table here, if you're like, I don't get it where I'm supposed to stop, and you plugged in, 0, I don't know what else you want to plug in, pi over 3 and pi over 2, like, that's where you'd get those values. Because 0, cosine of 0 is 1, that'd give you 4. That's this first point. Pi over 3 times 3 is pi. Cosine of that's -1 times 4. That gives you -4, which is that guy down there. And then the pi over 2 would make it 3 pi over 2, which would be 0, and that'd be back at the pole. All right, try number 2, guys. Very similar, but it's a sine, not a cosine.
So since it's odd, you do the half thing again?
Yep, you'll get 1.5 petals at the end.
I know.
I mean, you can think about, okay, technically it draws 6 petals.
Yeah,
It's just a repeat, and so a quarter of 6 is 1.5. Or maybe that's too many fractions for your head. It's good enough. Stop telling me more.
But why is it specifically the one in the bottom left for that one?
So if I did, like, if I plugged in thetas in between 0 and pi over 2 and, like, went in order, this would be point number 1, this would be point number 2, and this would be point number 3. Like, this is what I get when theta equals 0. This is what I get when theta equals pi over 3. And this is what I get when theta equals pi over 2.
What about the 2 pi over 2?
That's beyond pi over 2.
Oh.
So that's why we don't graph anything in that second quadrant on this one. Okay. All right, let's see how number 2 goes. I'll give you another minute here. Bless you. Nothing. Talk with each other. Do you have the same thing? Let's look. If I was graphing the whole thing, my petals would be, oops, I put that in the wrong spot. My petals would be at pi over 6, at 5 pi over 6, and at 3 pi over 2. Are we okay with that if I was doing the whole thing? All right, and then remember, sine is the one that starts at the pole. So if I'm graphing to pi over 2, I get that much of it. Again, if you're like, I am struggling with figuring out where to start and how much to graph, make a table. It's okay. That's not the end of the world if you need the table. But if you see this and are like, yeah, I can graph that. Awesome. Just graph. I'm good with that. And are we okay with why it's half the graph? Yes? And it's odd number, that will give you half. Okay. If it had been 4 sine of 4 theta, you'd only get a quarter of your petals. Okay. All right, any questions before I switch slides? Okay, what is what? What are we whatting? Okay, gotta ask me something, not just what. Are you confused on where the petals are? How many petals you see? What are we confused?
Like I know the coordinates, like the way I did it was I went down and around, so the petal was down there instead of on the first.
If you actually did it between 0 and pi over 2, though, your first angle should have been theta being 0. And sine of 0 is 0. So like the first point is the pole. And then let's say I did pi over 6. Plugging that in, 3 times pi over 6 is pi over 2. Sine of that is 1. 1 times 4 is 4. Second point is out here at the end of the pedal. And then the last thing I'd plug in would be pi over 2.
Wait, so for cosines, you start at the first point, and for sine, you start at the pole?
Yeah, because what's the sine of 0?
Sine of 0 is 0.
Yeah.
Cosine of 0 is 1.
Right, cosine of 1, you're out at the maximum. Sine of 0, you're at the pole. Okay. Pi over 2 would give you negative. All right, let's try some more. What are we doing on time? We're not doing all of these. Let me pick real quick what I want you to do. Let's do 4 and 5. And what's different about number 5? It's a negative. So just think about that for your starting point, okay? It's a little weird with them. And like which direction you would go. So try just 4 and 5 for me. That was a heavy sigh there. Really tired, okay.
This week has been too long.
It is Thursday. We're making it. So guys, on number 4, how many total petals should you end up with? Ooh, interesting votes. If we graphed the whole thing, it would have 8, right? Okay. 0 to pi is half of that. This is an even graph, even number of petals, so you just cut that in half. So you should have 4 total petals. You might have multiple half petals. That's okay. You can still have 4 total. Okay. You what? Yeah. petals. There's 2 half petals. And again, if you're like, man, that's so many dots and I don't know what order to connect them in, plug in some points and connect the dots, put numbers on them, help yourself out. It's okay.
I know the figures.
You're right, you can start out there. So then it won't go straight across. You see it? Yeah, once you like that idea. There you go. And like, well, this is good. So we have the main straight across. I don't. So they have to go forward. Okay. Like, I over 4, I over 2, things that would make you that'll make it so I would help it. Yeah, it's okay, like, you need to over.
Oh. Yes.
I just did the top half hits and even that's always even we just did a quarter was 5 or 2, so like
You start here,
I'm
and
guessing
then you go down
because it's
here.
negative.
Yeah, because this is really your first point that you fought, so it's kind of cool.
So you like the theta first.
So, but I don't know how to do it. That?
Did that mess up the beginning? Okay. Keep track.
It's this. Your original point is 8 over 4. And then you just want to put that again. Yeah, because it's hard to divide that by 2. That's and then it's
Yeah.
Then what it doesn't have 5.
yeah, that's
So
what
that
it
that's 5.
No, that's right. This one just looks like
I don't know, because you
not
went
quite up like this.
Yeah.
You're right.
So it probably is easy, right? You get 3 pi over 4 and 5 pi over 8.
You were
You get 5 before, and if you add the 5 with 10, you get 5 times.
Yeah.
But that's bigger than over that.
But maybe like some rules is like I don't understand it, but that seems right.
Then it would still be the whole Right, because the 3 pi over 4 one is actually down here. So you're connecting. And then I guess we do it like that.
All right, guys, let me put number 4 up here so you can look when you're ready to check.
We have the points.
No, we have that.
Let's see what I did on
This is it's not a lot of that straight. This is my gas right here.
Now, guys, I'll plot all the points for 4 just to help you see again how to connect them. It's cosine, so I start out at the maximum over here of 3, and then you go to the pole. And now remember, you're not going to go straight across from it. You're going to go 1 off from being straight across. So that means this one connects. I kind of missed the pole down here. And then you don't go straight across. You go 1 off from straight across. 1 off from straight across. 1 off from straight across. And that's 4 petals. And I messed up in the middle there. That's ugly. But that's what 4 should look like. I'll give you a little more time to work on 5, okay?
Wait. He's straight across.
And guys, if you're stuck at all on 5, if you're like, that negative is weird, do the table. Just do 0 to pi. It's okay.
I think I get it, and then I start plotting it and it just doesn't.
So like,
Hmm?
you check the performance.
Give me 1 sec. I'm doing it real quick. Okay. Right, because you're never going to go straight across. You can't do that without like changing directions. You can't be circular. So don't go straight across. Go 1 off from straight across.
So
Oh, so it's this way. Also, okay, so I'm confused on like the straight across. Like I feel like that's supposed to be sort of over here. Because
So
I
this
always
would be
think
straight
this is
across.
straight across. That's kind of the
So from the stop.
oh, from that way. Oh, okay.
1 off.
Okay.
And so same thing here. Like this is straight across. 1 off.
Oh,
And I have one question. So, how do you know to draw this? And then how do you know when to stop when you're doing the straight?
So you know it has 8 petals, right? And you do 4.
Yeah.
So I'm just counting, and like there's half the petals, so there's 1, 1.5, 2, 2.5, 3, 3.5, 4.
Oh, okay. So it's simpler than I thought it was.
I know that's what. So when I was doing that, I was like, 1, 2, 3, 1, 2, 3. Is that right? And then I did it wrong. I only have 5 minutes. There's this stuff.
You guys want me to put it up here because we're running a little short on time? And again, I would recommend doing this one by just plugging in a couple of things. You don't have to plug in a ton of stuff. You still know, with it being sine 2 theta, you should have 4 petals, and they should be on the 45s if you were doing the whole thing, or the pi over 4s, right? Like, is everybody okay with these 4 dots? Like, we get that. It's just a matter of like, which ones do I use with the window, right? So I would just plug in a couple of things. Start at 0 because it's from 0 to pi. And what is the sign of 0? 0. Okay, we know that sign starts at the pole. Great. I'd plug in pi over 4 next. I'm using pi over 4 because I have to take it times 2. And what's pi over 4 times 2? Pi over 2. What's the sign of pi over 2? 1. 1 times negative 4. Okay. That means this guy down here is the petal you draw first. So that's all I need to draw because I know I need 2 full petals. I start at the pole, I come down there, come back up. What's the only other petal I can connect to without doing weird things with my drawing? Top left, right? Second quadrant. So I know I need, I made that a big petal. I know I need that one. And I stop because I know I'm supposed to have 2 petals. If you are like, I'm struggling with the how many petals, where to end, all of that, then make the full table. There's nothing wrong with that. We're just trying to move towards seeing this part of it, okay? Your homework, I believe on the worksheet, there are no intervals. It's just graph, okay? And I think your homework's front and back, right? A few graphs on the front and then questions on the back.
Where do we put
Lines are ugly, aren't they?
So,
So you got 0, good. 2 pi over 5. What is 2 pi over 5? You know.
0.4, so I know it's like here.
No, like if you actually considered it. So like pi over 5, that sort of thing. So how many times does 5 go into 18? 3. Okay, with how many left over? 3. Okay, so that makes it 30. How many times is 5 go into 30? Okay. So 180 divided by 5 is 36. 2 times 36 is 72. So it's like almost there. So what I would do is literally count 1, 2, 3, 4, not quite to 5. And then I could go from there and go 1, 2, 3, 4, not quite as far. There we go. 1, 2, 3, 4, not all the way. Like you're just spacing. It's ugly. Yeah. I like the 5s very much.
When we have full
Technically, that's what's happening on the hot.
so it's like you're around here, called.
Yep.
So then, why for the odd ones, like a quarter of the graph, then like half?
So
like
how
that?
many petals are we technically drawing?
6.
Right. So if I go through a quarter of 6, what is a quarter of 6?
Quarter of 6, like
Right. So even though you go
you draw like a petal and then half a petal.
you get half of the visual graph.
So why is that only for odd
Because even you actually, it rotates enough that you get all, if it says 4 theta, you get 8 different.
Oh, so then if you're dividing.
Yep, it's weird.
Do you choose the points that you, like the degree that you place based on this? Like you see that, oh, this is pi over 4.
Yes.
So, okay, so that's why like pi over 2 wouldn't work.
Pi over 2 works. You can do that.
But like,
Then you just get pi.
so,
And what's the sign of pi? Do you get why I'm saying you get pi?
like I have 2 pi, or 2, oh yeah, 2, yeah. Pi, 0. Oh, yeah, you're right. Okay, because I plugged that in, and then I was trying to, like, how do I get this? Okay, that makes sense. Got it, thank you.
Yep. I will target negative, and then pi over it's like every 72.5 or 72 degrees, something like that. Have a couple of 5s on your homework, I'm sorry. Yeah.
Are you doing fiber graph today?
Do we need our calculator?
No.
Yeah. Little teeny bit.
Yeah, because I saw like on the
Some dog?
like
Some, like, what?
like the MTV.
We have a game on Tuesday. I don't know. No?
Your schedule is like
I do have it.
Danny, how is it?
That's right. Like, you never fiber graph.
Why?
Still gives us all of it. Something that is.
Use all
What if I like I'm fucking that fun.
I don't know. I was like, I'm trying to do it like this.
We're playing about
It's honestly like,
yeah, they're coming in. I want to see that. This is
yeah.
probably they are. I think Open JV beat somebody that wasn't. We lost 2-2.
What was that again?
Yorktown. They were number 2 in the state last year, so kind of excited. But like the top 2 balance.
He deleted it. No, he didn't. What show? I found it. Every once in a while.
Yeah, it's not even.
Oh, sweet.
He says it. He couldn't
I'm not.
Yeah.
Hi. You almost popped up on
I have something to carry today.
Yeah. Yeah.
It's like indoors.
Basically, what it does, it goes forward a constant amount while it turns left, turns left a little bit. So if each sign it gets back. And yeah, this is what it ends up happening. Perfect. that like fills in. And then it comes back. It makes a little.
Hello, guys. All right, happy Thursday. We are moving on to 8.4 today. You're going to learn how to graph roses. First, we'll do a little warm-up, and I'll check your homework. Then we'll do the notes, and your homework again is on a worksheet. So, guys, your warm-up is actually in your packet. It looks like... looks like this. I do want you to graph these on your calculator, so if you forgot your calculator or just don't have it with you right now, partner up with someone who does so that you can look at this together. And I will give you a quick calculator lesson on how to graph polars on your calculator. No, that's what I'll show you. There's actually a way to make it a theta. It's in your notes packet. Yeah, I know. This morning I was like, wait, where did I put it? All right. Okay, everybody have your calculator out that has a calculator? Okay, we need to change a couple things to make it so you can actually graph polars on your calculator. So go to mode for me. You're going to want radian highlighted. That's the third one down. And then below that, you probably have function highlighted. Go over and make sure polar, P-O-L, is highlighted.
Radian and polar.
Radian and polar.
Okay.
Then when you go to y equals, it's not a y equals anymore. It should be an r equals.
Whoa.
Yeah. And if you push x, you don't get x, you get theta. What? Okay, go to mode. Radian, polar. Okay, then go to y equals.
Oh, that's how you have to.
Yeah, that's it. And then you can graph and like I missed something. All right. It is. All right, guys. So work on the warm up, talk to each other, see what conclusions you can come up with. And I'll come around and check your homework. What? Yeah, it's actually in your packet. Mode? Oh, how do you get theta? Push it. No.
Yeah.
Got it.
You got two graphs going on at once.
What values should I put in for my min and max of the window?
So 0 to 25, or you start at zoom trig. Guys, if your graph is being kind of weird, take zoom trig, and then it should fit nicely. But it's a.
Also, I'm also kind of like in an of graphing.
Yeah. All right.
Was I supposed to worry about this raise?
You're like, I was just graphing a weird thing. There we go. All around. I see a pattern. I know. Oh, yes, yes. She just turned one. I'll do it.
Sorry, you know, this is like a question about the logic analysis. Like, maybe you just, I know, the rest of your experience. Good morning, I'm not
Well, I keep track that you
Yeah.
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 10 minutes of 40 minutes.
Second year, I have the first one.
Let's see how.
Oh,